Very good. Hi, my name is Jakob. We so far had some really cool talks. The bar is actually raised pretty high, and I will try to keep that standard. So today we're going to talk about how to manage shared secrets using basic Unix tools. Let me start with a question. What are shared secrets? Shared secrets are basically all the secret things your team and your servers have to know. Most modern web applications integrate with different services one way or another. It could be something like your database, a third-party API, another service in your infrastructure. And often enough, you need something like credentials, an API token, or a certificate in order to be able to establish a trusted connection. Handling such secrets in a working team and during deployments can be actually quite challenging and sometimes even intimidating, and it's even often a source of error or later on security breaches. Today we want to explore some directly applicable techniques that we can use to make that task a bit more easy. So let's start right in. There are several approaches for handling secrets in an application. The oldest one I know, and I admit I used it, is having a constant in your source code. And this immediately solves the problem of keeping secret information in sync, right? So in sync between your team members and your deployments. Whenever you need to change a password, you can just change it. First of all, you cannot really consider this a secure option for obvious reasons. First of all, everyone who gets access to the source code will also be able to read all your secrets. And furthermore, stuff like key rotation will become really tedious, maybe, because if you iterate password changes over time, you would have to change your source code, recommit your entire source code, deploy it to change a secret. And beside that, it becomes really hard to deploy the same code to more than one location, like staging and production and QA, whatever. So an evolved alternative to that, maybe a common alternative, is to store the secrets you need in a configuration file that is not checked into version control. And this solves the pending issue of having clear text secrets in your source code. But it generates new challenges. First of all, the key takeaway from the previous slides is now gone. The synchronization does not come for free anymore. If you change the mentioned password, your team members and your servers, they have to know. So you need a channel to distribute the knowledge. And beside that, there's an unencrypted file on the file system of your servers, maybe on the file system of your local machine, contains your precious secrets, feels kind of not so secure. And in addition, you get stuff like lockstep scenarios on deployment, so you change a variable name in source code and in your configuration, you have to make sure you deploy it at the same time. Stuff like this can give you problems. So to completely eradicate reading secrets from a file system in clear text is using environment variables, like 12-factor app, for example, suggests. An approach like this will keep clear text secrets away from your committed source code and away from the file system, at least of the deployment as such. In addition to this, configurable deploys get more easy. You can just deploy setting different environment variables. But it still leaves you the burden of finding a way to securely set these values and distribute them among your teams. So in the end, all three approaches I know of doing this are kind of like a trade-off. Either syncability is super easy or not. So this means we need some kind of a synchronized shared password store, which is encrypted, can be decrypted by all the team members individually, and ideally without the use of a shared password. To do so, we will use two pretty nifty tools, which I give a brief introduction to. The first one being GPG. I think Who here work with GPG on a regular basis? Okay. So I will give a really short introduction on what GPG is, not too deep, just the stuff we need to know. First of all, it stands for GNU Privacy Guard, and it is basically an implementation of a public key infrastructure. You may have heard of it in the context of email encryption, which is kind of like the most common use case for GPG as far as I'm concerned. It basically works like this. If you create a GPG certificate, it will contain a correlating public and private key, which is a symmetric key scheme. In addition to that, to these two keys, the certificate will contain a GPG ID, which is unique, and you can use it to refer to the certificate. So this means if two people out of the audience send me their public keys, I would be able to send them, I could encrypt the file with a public key of one of the recipients, and he would or she would be able to decrypt that file using the private key. And I would use the GPG ID on my machine to reference which public key I want to use. It's basically like a numeric representation of the name of the person who sent me the public key. GPG has some more features like digital signatures, which are not relevant for the examples we're up to see. So we stick to public-private key crypto. The second tool I want to talk about is Pass. Anybody know Pass? Cool. So the developers of Pass call it the standard Unix password manager, which is a very, very bold statement. So what they mean is it adheres to the Unix principle, which means it does one thing, but it does it right. And which again is a bold statement. What it does is basically a convenience wrapper around GPG. Because if someone works with GPG, it can be kind of, I would say, complex to work with GPG. I don't know any Unix tool that has more command line flags than GPG. It's, yeah. Pass gives you a convenience wrapper around GPG. Basically, it allows you to encrypt secret information with either one or several public keys, and all the information you encrypt will be stored as flat files in one directory. And this directory can be shared using version control. This effectively gives you something like an encrypted pool of information that is shareable, but still secure, without any well-known passwords, of course. And in case you're interested in checking out Pass, it's actually super easy to get. You can install it on Mac using Brew, and I think all Linux distributions I know have it in their package managers, and you can just install it. So let's go to an example application and bring Pass and GPG in practice. What we want to do is build a super simple JavaScript application that should display certain statistics about a GitHub user, maybe private statistics, so we need access to the API, to the GitHub API, which is possible using a username and an access token you can generate for that username. And these two things, the username and the access token, will be the shared secrets we want to manage or take care of. Everything will be hosted on a platform as a service hoster to simplify and streamline as much of the infrastructure as possible. I think most people know what platform as a service is, because we're have a DevOps background. In case you don't, it means you don't have to manage bare metal servers or virtual machines on your own. Instead, the deployment occurs on an application basis. You basically submit your application, which could be a JavaScript file or Ruby file. You just give it to the hoster, and he does everything else for you. Scaling, load balancing, and stuff like database integration is all taken care of. The simplest platform as a service hoster I know I work with is Heroku, so we'll use Heroku for the example. The application as such is not important what it does. The important part is that's one file, index.js, contains an Express.js server. Express is a HTTP server framework for JavaScript, and it uses two environment variables, which are quite important. These are the credentials we want to use to make API calls to the GitHub API. Heroku itself deploys using Git. So that thing, I would check it into my Git repository, add the Heroku remote, and would just push it to Heroku, basically. Heroku gives you a nice example on how to set up your Heroku project, so that's like a 1-minute task. And in principle, that's literally everything all you have to do to get the application running. You could just now access it online. But it wouldn't start because we're not setting the environment variables, right? So the Heroku CLI command line interface gives us a way to set these environment variables, which looks like this. It's actually quite easy to just set them. The application will restart and the environment variables will be persisted online in the application. But to execute this command, I would have to manually type these secrets. At least the API token is pretty secret. And that will be true for any person who wants to deploy the application. So that doesn't really scale for even a one-person team. So what we want, again, is a way to retrieve the secret information automatically during deployment so that this clear text stuff can go away. So let's use Pass to build a secret store. As I mentioned before, Pass operates on a single directory. And to get started, you basically define the directory you want to work on. And that's unfortunately the only way to configure the Pass directory is to set an environment variable. But that's just by design. You decide which GPG ID should be used for encryption. Could be several. In that case, for an easy example, a simple example, it's just my GPG ID, and that's actually my GPG ID. Then you just call pass init, and you're done with it. What this does is creates a secret store inside of that directory. But what can we do with it? So what we can do is we can add secret information pretty straightforward. You would just call pass add, give it a path, which is basically a key or the identifier of your secret, and it will ask you on standard in to type the secret twice, so you don't have any typo, and it will be stored encryptedly. The other side is you want to retrieve the information again. You can do that using, who would have guessed, PassShow. PassShow, on the other hand, will give you on standard out the secret you just added. It will do the decryption on your machine, of course, only if you're in possession of the private key, of the unlocked private key, that is matching the GPG ID that was used for encryption, for obvious reasons. And the fact that it's printing the secret out on standard out is particularly interesting because it is a very, very convenient thing if you want to use it inside of scripts. We will come to that in a second. If you would take a look into the secrets directory, just this one, it would not contain much surprises. You will have two .gpg files, these two, which basically, if you just look into them, it looks like raw white noise. It is the GPG encrypted secret information you just added. The only special thing is the .gpg ID file, which contains the used GPG IDs. So Pass knows whenever you call pass add with which GPG IDs to encrypt. And I think that is it's very nice to see how few magical elements are involved to get Pass running. It's actually virtually no magical elements. There are no surprises in that directory. You could even use different GPG IDs for different subdirectories. So you could have a .gpg ID file in that production subfolder and one in a development subfolder. So you could do some basic access ACL-like concept that a few people can access the production secrets and all the developers can access the develop secrets. If you're interested, you can talk to me after the talk about that. And of course, you don't have to use bare metal tools like find to look into it. You can just use pass-ls and it will nicely print the content inside, of course, only the structure, not the content, of the secret store. But so far, that's all pretty nice, but how can we use that in the configuration example we've seen before? Well, when you're on a shell, you can easily use it like this. So you read the values out of the secret store, assign them to variables, and then you call, config set again, but this time without knowing, physically typing the secrets you want to use, which is like the next step towards a more secure chain of handling secrets. So far, we have accomplished a secret store in a single directory, but it's only for one person, right? I initialize it with my GPG ID, so there's not really like sharing involved with other people. So we're not really done. What we want is working with a team. And when you talk about working with a team, there are two key moments, or two key moments in the life of a team, and they are called sometimes, or referred to sometimes, as rolling on and rolling off. Rolling on means that an additional person joins the trusted circle of team members. And this involves, in general, granting certain privileges to that person, like access to secret information, maybe access to parts of the deployment, or access to the entire deployment infrastructure. Like all the things, only people that are in the trusted circle of team members that are inside. And on a side note, it is a really, really good idea to have something like a roll-on security checklist. We try to establish this in most projects. And it should contain like a standard procedure. Sounds a bit officially, but it's not that official. You would put stuff on this like, are they the new, you would go through this list whenever someone joins, and you would have stuff on it like, are they using a password manager? Is the hard drive encrypted? Are the SSH and GPG keys password protected? Stuff like this. Mostly sanity checks, but they vastly improve the overall security inside of the team. Nevertheless, when this person joins, you want to give them access to the secrets. With Pass, that's actually quite easy. So let's pretend two people join our team, Ada and Alan. What I would do is, I would get their public keys. They could just send them to me or distribute them among the team, which means when I have the public keys, I have the GPG IDs. And so I would just call pass init again, but this time with more GPG IDs. And note, it's still the same directory we used beforehand. So what this will do is it will re-encrypt everything inside of this directory. If we would take a look into the .gpg ID file again, it would now contain 3 GPG IDs instead of 1. What we have now achieved is that if I share this secrets directory with the new teammates, they will be able to retrieve information out of it or add information to it. That was actually not much work. But it's a different story if you talk about rolling off. Rolling off is on a secret store access management, not much more work. You would have guessed you will just call, so in this case, Alan happened to leave our team, so his GPG ID will be removed. We will call pass init again, and he won't have access to the directory in the current point of time. And that is an important thing, or an important note. Whenever someone leaves the team, of course you can revoke access to the secret store, but the leaving party is still in possession of the history of the secret store. So technically, they have still access to everything. And what this implies is that whenever someone leaves your team, you should focus on rotating all the secrets that were in use. I know that is tedious, and I've worked in projects where we didn't do it because it was so much work, given the overall legacy system architecture, and that is a really, really, really bad thing to not do it. Oh, I just skipped a slide. So after you call pass init again, it's actually not that important, that slide, because you can guess what now in .gpg ID file contains, right? Just one less GPG ID. So the point I was making is part of your roll-off checklist after revoking access to the secret store should be rotating all your secrets, because it's the only way to make sure that the leaving person can do no harm. And that isn't even related to people intentionally want to do harm. It's more like when I leave a project, I may have the source code still on my hard drive and maybe some passwords, but I don't care. I'm not really on the project. Maybe I change employer or whatever. So even if the person is not intentionally is not intending to do harm, then not being conscious about still having access can be really harmful. But one thing that is important to note about the secret directory, and that's what I experienced, when you have all the secrets in one dedicated place, like source code, the rotation, while still tedious, can become slightly less tedious, because there's one single source of truth for the secrets that are in use throughout your system. So let me quickly recap what we have achieved. So far, we have built an encrypted secret store that is living inside of a single directory. This directory can be distributed amongst your team members like regular source code, for example, by using your trusted version control system. And this gives you an encrypted and versioned password store. Because of the nature of Pass, the process of people joining or leaving the team becomes as streamlined as possible without compromising security. And key rotation can maybe become a bit less tedious. So we're right on time. We have 3 minutes left for questions. Thank you very, very much for your attention. There is an online version of this talk, which basically contains all the source code examples, a few more links, how-tos on start with GPG, or how to get started with Heroku. And that's all from my side. Thank you very much. We still have like 4 minutes for questions, so in case there's anybody interested to ask something. There's someone waving. Can we get a microphone there? Thanks.
I can give you the mic. Interested to do this?
Well,
yes.
Hi. Really great talk. Thank you very much. I just have one question. How do you audit?
Speak up a bit.
How do you audit this? This is my question.
Audit?
Yeah. Can you audit who is accessing which secret at which time and why?
Because the nature of it is a distributed. It has a distributed nature. When you do something like Git, you cannot really audit access to the reading access to the store. But what you get is you have an cryptographically secure audit of writing access. So when you use signed commits, for example, in Git, I can just speak for Git because that's what we use for that. You can really see and you can validate if a secret had been changed or how often it had been changed. So you get an auditability on that side, but you're still distributing it among people, so you don't really know when it is accessed for reading. That's unfortunate. Thanks. Any more questions? Okay then. Thank you very much.